Have you ever looked at the Burj Khalifa piercing the clouds over Dubai and just wondered, how? How did humanity build something so massive, so impossibly tall, right in the middle of a scorching desert? This isn't just a skyscraper. It's a statement, a testament to pushing the very limits of what we thought was possible. But behind its gleaming facade lies a story of colossal challenges and ingenious solutions that redefine modern engineering. Today, we're going deep into the heart of this megastructure to uncover the secrets of how the Burj Khalifa was built. The first and perhaps most fundamental problem was the ground itself. Dubai isn't built on solid bedrock. It's built on weak, loose sand and soft sedimentary rock, the worst possible foundation for the world's tallest building. Imagine trying to stand a giant needle on a cushion. Any normal foundation would simply sink or tilt. The engineers had to come up with something completely revolutionary. Their solution was to go deep. They drilled and installed 192 massive friction piles, which are essentially long, reinforced concrete columns, plunging over 50 meters into the ground. That's deeper than a 15-story building is tall. Now, these piles don't just sit there. They work by creating immense friction against the surrounding sand and soil. It's like gripping the earth itself. All 192 of these piles were then connected at the surface by a gigantic 3.7-meter thick concrete mat called a raft foundation. This raft, weighing over 110,000 tons, spreads the building's enormous weight across all the piles, creating a foundation so stable it could support a city. This was the first monumental victory against the desert. With the foundation secure, the next battle was against the desert's most formidable weapon, extreme heat. Temperatures in Dubai can soar past 50 degrees Celsius. In that kind of heat, concrete cures way too fast. It cracks, weakens, and becomes structurally unsound. Pouring standard concrete during the day was simply not an option. So, how do you build a concrete tower in an oven? First, the team had to invent a whole new kind of concrete. They developed a special high-density, low permeability mix that was incredibly strong and could better withstand the harsh conditions. But even that wasn't enough. The real genius was in how they cooled it. For every batch of concrete mixed, a significant portion of the water was replaced with crushed ice. Think about that, they were literally adding tons and tons of ice into the concrete mix just to keep its temperature down. Then, they turned the entire construction schedule upside down. All major concrete pouring was done exclusively at night, when the air and the equipment were cooler. This combination of a bespoke concrete formula, a massive ice-making operation, and a nocturnal work schedule allowed them to pour a perfect, super strong concrete core, one level at a time, right in the face of the blistering sun. As the tower climbed higher and higher, a new set of problems emerged. Gravity and wind. First, how do you get wet concrete all the way up there? We're talking about heights no one had ever pumped concrete to before. A normal pump would burst under the pressure. The project required the development of the world's most powerful concrete pumps. Massive machines capable of pushing the special concrete mix vertically over 600 meters. This was a world record, a feat of hydraulic power that had never been attempted. Each pump had to be perfectly calibrated to ensure the concrete arrived at the top with the right consistency to be poured. Then there was the wind. A building this tall acts like a giant sail. The powerful winds of the upper atmosphere could cause it to sway dangerously. The architects at Skidmore, Owings, and Merrill knew a simple square or rectangular design wouldn't work. The solution was the Burj Khalifa's iconic triaxial Y-shaped floor plan. This wasn't just for aesthetics. This design is an aerodynamic masterpiece. Each of the three wings has a different length and steps back at different heights. This irregular shape confuses the wind. Instead of creating large, organized vortices that would cause the building to rock back and forth, the wind breaks up into smaller, less powerful currents. The result? The tower is incredibly stable, even in a storm. This design was so critical that it underwent over 40 different wind tunnel tests using a scale model, simulating every possible wind condition Dubai could throw at it. But all this incredible technology, the piles, the ice concrete, the pumps, The wind-defying shape would be useless without the people. At its peak, the Burj Khalifa construction site was a city in itself, with over 12,000 workers from more than 100 countries on site every single day. Coordinating this massive, diverse workforce was a logistical challenge of epic proportions. And overseeing it all, like giant metallic guardians, were three of the largest tower cranes in the world. These cranes were anchored to the building as central core and had to climb as the tower grew. Imagine operating a crane more than 700 meters in the air in high winds, lifting tons of steel and glass with pinpoint precision. The skill of these operators was nothing short of heroic. It was a perfectly synchronized ballet of man and machine, running 24 hours a day, 7 days a week for 6 years. Finally, on January 4, 2010, the world watched as the Burj Khalifa was inaugurated with a spectacular display of lights and fireworks. What started as an ambitious dream in the desert had become a reality. It had overcome unstable ground, extreme heat, and the forces of gravity and wind. The Burj Khalifa is more than just the world's tallest building. It's a monument to human ingenuity, collaboration, and the relentless desire to achieve the impossible. It proves that with enough vision, innovation, and determination, there's no limit to what we can build. Thank you so much for watching. If you were as fascinated by this engineering marvel as I was, don't forget to hit that like button and subscribe for more stories about the world's most incredible structures. See you in the next one.